Hello, EarthSky friends. Happy Eclipse Day. I'm Deborah Byrd, EarthSky's founder and editor-in-chief, and today we have something special, a total eclipse of the sun. And we are streaming this eclipse thanks to the generosity of our good friends at timeanddate.com. And I am here with Dr. C. Alex Young. Alex, hello.
Hello, it's exciting.
I know. Can you introduce yourself to folks?
Yes, my name is Alex Young. I am a solar astrophysicist and I study the sun and space weather, and I love to follow eclipses and aurora.
Oh, we love all that stuff. So the eclipse, the total eclipse hasn't started yet from anywhere on Earth. It's going to start at 16:58 UTC, which is 11:58 a.m. Here in Austin, Texas. So,
That's right.
so what's going to happen, Alex? Tell us about it. Should we watch that that little animation as you
Yes,
talk about it?
that would be
Yeah,
great.
we have a
Yeah.
little animation we can show you.
Yeah, we're going to show you something from the NASA's Scientific Visualization Studio, which is a real data-driven visualization. And so here you can see just the beginnings of the moon's shadow. This is the outer part of the shadow called the penumbra, which is reaching over the far end of North America, getting up into the Arctic Circle. And shortly we will see this more towards the center of it. We'll see the darker core called the umbra, which is the part that, if you're underneath it, allows you to see the total solar eclipse. And there it goes. You can see it's kind of stretched out. It's getting to Greenland, and then it will travel over Greenland. And once it leaves that, it will get to Iceland. It'll be traveling at 3,400 kilometers an hour at that point. And then it curves around, passes just to the west of England.
Oh, let's put up the other one. We have another
Okay.
one. Hang on.
We
have the other
view.
half of that.
So we can see from the beginning of it that the partial eclipse has already reached into the northwestern part of North America. In fact, we have some colleagues who are in Alaska, but they have not been able to see it because of clouds.
And let's switch to the second
so
half
now we
of it.
see the umbra passing by the western part of the British Isles and Ireland, and then it just gets to the edge of Spain, touches Portugal, and ends just at France. And that ending is right when we get to nighttime. So that dark line, that is the terminator, where the eclipse ends as daylight ends and nighttime begins. But you can still see the partial over the Atlantic Ocean.
Oh, and you know, I've heard that, like, it's so interesting the way this path, the second half of this eclipse path that we're looking at again now, where that little black dot is the dark shadow of the moon, and people within that little dot are seeing the total eclipse. And it's so interesting how it goes into Spain and Portugal and then goes into the nighttime, because what that means is that the people in Spain are going to see that eclipse almost at sunset.
Yeah,
and that's going to make for some really amazing.
It's actually very spectacular. Yeah, I saw an eclipse in Argentina in 2019 at sunset over the mountains, and it's a pretty amazing view. Partially because if you're near mountains, it's very low in the sky, so it's the light is going through a lot, or the shadow itself is going through a lot of clouds or a lot of atmosphere. And it means that you have a really good chance of seeing shadow bands, which are these very exciting, wiggly little shadows, similar to what you see on the bottom of a pool. They're called caustics. And you have to have a lot of atmosphere to see them. You're seeing turbulence in the atmosphere.
Yeah, and let's switch because the total eclipse hasn't started on Earth yet. We are now 5 minutes away from that happening. And actually, when it does happen, I don't think, and we're looking at a feed from, or we're not right at this moment, we're looking at a still image. But when we go back to the feed, we're going to be looking at a feed from timeanddate.com. And they have an amazing number of locations on Earth that they're going to be broadcasting from. But I don't think any of those locations are at the very beginning of the eclipse. They are going to catch the very end of the eclipse on an island just to the east of Spain, right before the eclipse goes into nighttime. I think the island is Mallorca. Is that how you say
Yeah,
it?
the very beginning of the eclipse actually happens over Siberia, so it's not a particularly easy place to go see one. Though I'm sure there's some people there who are enjoying it, because I will say eclipse chasers will go to all ends of the Earth, from Siberia to Antarctica to see an eclipse. I've been to Antarctica to see one, but I haven't been on the glaciers right in the main part of Antarctica, which is where some of the most recent ones we're seeing from.
And I'm going to switch back into the time and date feed that we're going to be watching. And you can see that they are right now broadcasting from Leon, Spain, which is nowhere near Totality yet. Totality doesn't start in Spain for what, Alex, about an hour from now? Something
Yes.
like that?
Yeah.
Yeah. So we're going to be here. Alex and I are going to be here for a while. And we are so grateful to you all for being here. Not much is going to happen there in Spain, but I think their first one where they have a feed, they're going to have a feed from Iceland, is I think their first, their northernmost, their earliest.
It reaches Iceland at 12:43 Central, 1:43 Eastern Time. And I'll also say that the greatest eclipse, okay, the maximum when you have the longest totality, is just off the coast of Iceland, and that's happening at 12:46 p.m. Central, 1:46 p.m. Eastern.
And so that shadow of the moon is going to just be sweeping across the Earth with almost no one seeing it for quite some time until it gets to Greenland. And then it's going to take 28 minutes to go across Greenland. I heard that Greenland was clear, but I heard that Iceland was cloudy. That was maybe half a day ago. So we'll see if it's cleared up.
And so can I put up an image?
You sure can. You sure can.
All right. So let me show people. So
let's go to this screen for you to put it up.
I work on a website with my wife called The Sun Today, and this is the website. It's actually not letting, I didn't quite get it right, but if you go to thesuntoday.org, this is the top part of the page showing you details about the eclipse. But in order to really get a good look at it, we added one called eclipse.thesuntoday.org. It's called the Eclipse Kit. And if you go there, when you get to the page, you can see the timing. So the eclipse has already started, and it says there, eclipse underway. And if you click on the eclipse map, you'll actually get a live map that will show you the eclipse. You can follow it, and you can even go and see the clouds. These are the yesterday's clouds over Iceland. So you can see the path that goes off the coast of Iceland. There's a lot of clouds there. So.
And which satellite is that, Alex?
That is the MODIS Terra satellite from NASA. This is the daily image, but if you go to our website at Eclipse Kit, the eclipse.thesuntoday.org, you can pick the most recent image of the clouds and see what's happening right now. So,
and let's just jump back real quick to this feed, because totality is about just a few seconds. There it goes. It's 11:58. So the moon's shadow should be touching down on Earth at this moment.
Oh, are you showing? are you showing the animation or?
No, this is the actual feed from Leon, Spain.
Oh, okay.
So as I said, this is a feed from timeanddate.com, and they don't have, and NASA doesn't have, and the European Space Agency doesn't have. I don't know of a feed from Siberia that's broadcasting the
Oh, right. I
eclipse
see.
at this
Yeah. So
moment.
it's 11:58 Central, so it just reached Siberia.
Just reached Siberia. So you can't see anything happening on the sun yet.
And
But
it's
yeah,
going to
let's
take.
go. Go ahead,
Go ahead.
Alex.
Well, I was going to say it
Oh,
takes 14 minutes for it to get to Greenland.
yeah, okay. 14 minutes. And let's go back to what you were talking about. So finish telling us about this.
Yeah. So if you go to eclipse.thesuntoday.org, Eclipse Kit, and you click on the interactive map, you can click on any point on the map and view what you would see from your location. But you can also overlay clouds so that you can get the most recent clouds. And this was a snapshot from this morning showing clouds over Iceland. Iceland. Fortunately, it looks like Spain's going to be okay so far, but it's going to be tough in Iceland.
Yes, we got some images this morning from EarthSky's Will Triggs, who is in Spain to view the eclipse. He's in Leon, and everything looked nice and clear. So we have high hopes for Leon, Spain, which is where we will also be broadcasting from on this stream.
Yeah,
so we're more certain about Spain than we are about Iceland and Greenland.
It's too bad, because I have a colleague that who runs something called aurorasaurus.org, which is an aurora chasing citizen science project. She is in Iceland. One of the things that I've wondered for many, many years, as she has, is can you see aurora during totality? So totality doesn't get completely dark usually, but it gets very dark, more like a dusk time. But if there's enough activity, conceivably you could see aurora during totality. So that's why she's there. It's not looking too good right now. Solar activity is not really super high, but it's not out of the question. So fingers crossed that they might actually get lucky and see that. That would be like a super bucket list item for me.
Absolutely. And let's talk about, can I go to the image that you added that says latest sun?
Yes. Yeah.
Let's look at that. Is that from today?
Yeah, this is just from about an hour ago. This is from the Solar Dynamics Observatory, or SDO, which is a spacecraft that looks at the sun in wavelengths of light we can't see here on Earth. This is extreme ultraviolet. This is the sun that we look at, and actually we look at for EarthSky every morning to do our space weather forecast for the day. And what you're seeing here is all kinds of really interesting things. There's that really big dark patch. That's what's called a coronal hole, which is where very fast streams of particles called solar wind can come out. Those can create aurora when they hit the Earth. And then you'll see that little snake-like wiggly thing sort of down towards just below the center. That's called a filament, and those things can erupt. And in fact, when we go back to the live feed, you're looking at a different wavelength, but you'll see more structures like that, and you're seeing the same thing, but in a different wavelength of light.
And Alex, tell us about, just what's going on the sun in general. Like, just a couple of years ago, we were at solar maximum. Like, what is solar maximum, and where are we now?
Yeah, so the sun, just like hurricanes, hurricanes have a yearly cycle, and there's a hurricane season. Well, the sun has a cycle called the solar cycle, or activity cycle, and we measure that by the number of sunspots that we see on the sun, and that's about 11 years. So it goes from low to high, back down to low, and we just passed the peak. That peak we call solar max, which was in 2024. We had some really big, fantastic solar storms. In May of 2024, there was aurora seen all over the globe, close to the equator, which is very unheard of. That was maybe once in a 20, 30-year storm. We had a fairly big one in October. I saw aurora in Maryland. People saw aurora in Texas. People saw it in Florida. And we're coming down from that peak. However, we're still kind of in the time frame of solar max. There's the peak of it, but there's sort of a period of a couple of years. But we don't have it right now. But what that means is as we go back towards solar minimum, we start seeing less and less periods of less and less activity. But it doesn't mean we can't occasionally have a little burst of activity. And so we expect to still see some reasonable activity over the next couple of years. And one of the crazy things that scientists discovered relatively recently is that as you're going towards solar minimum, some of the biggest solar storms in history happen. So that's also a big possibility. So, we're excited, and we keep an eye on it every day.
We do. And so Alex and I are up in the pre-dawn every day, working together on that. I'm working on EarthSky's newsletter, which we'd love to have you guys sign up for our newsletter. That we have about 250,000 people so far have signed up for it, and we are thrilled about that. So but one of the things that Alex and I do together every day is what we call our Sun News Update. And you can get that update at earthsky.org. It's on the homepage every single day, and it's updated every single day. And Alex is very dedicated to that, as am I. We're all dedicated to it. Yeah. I think that's one thing that kind of sets EarthSky apart. There's a bunch of dedicated people working for EarthSky. And so someone is asking, Alex, do any satellites have a live view from space? And we were just talking about that. We don't know. ISS, no.
ISS does not. And ISS is actually moving so quickly, it's very difficult for it to see a lot, though it has occasionally caught the shadow. Now, some of the weather satellites goes, and what was it? Meteosat do capture the shadow, and I've seen videos of the shadow moving across the Earth, but I don't know if it's live. I've only seen them, shortly after the fact. However, we will see definitely images and video of the shadow. But I will add one thing. Spacecraft, depending on their orbit, see their own kind of eclipse, which is very exciting. They often see the moon move in front of them and block the sun out. And in fact, if you look at today's sun news on EarthSky, we have an image of one of the telescopes, and you can see the moon move by the telescope. And so it's actually quite common. We have them several times a year. For the Solar Dynamics Observatory, we get these eclipses twice a year. And in that case, the Earth goes in front of the spacecraft and blocks out the sun. And we have two of those eclipse seasons. And interestingly enough, solar and lunar eclipses come typically in pairs in a season. So right now is the second season of the eclipse season. And this is the solar eclipse, but that means there's a lunar eclipse coming. And in fact, on August 27th and 28th, we will have a partial lunar eclipse, but it's a deep partial, almost a total. And most of the United States, for example, will see that happen. So here you're seeing the moon move from right to left, and that umbra, that's the shadow cast by the Earth. So for a solar eclipse, it's the shadow from the moon that we experience. But for a lunar eclipse, it's the opposite. It's the shadow of the Earth. And that umbra part is where you see totality. So you can see the moon almost goes completely inside of it. So it's just shy of being a real total. And that's why we call it a deep partial.
And you guys don't let that date, August 28th, fool you, because it's happening overnight on August 27th.
Yeah,
So a
this
lot
is
of these
actually,
dates,
yeah, they're universal time.
they're
So
universal time. So
if
it's
you
like
look
Greenwich
down
Mean
in the
Time.
right, yeah, if you look down on the right there, you see the eclipse actually starts at 9:24 p.m. August 27th, the night of August 27th. And so that's a really important, because otherwise you're going to miss it.
And you guys, this is a fantastic, deep, as Alex said, a deep lunar eclipse. And so do you think, Alex, that they might see a little redness in the moon
Oh, they're
shadow?
going to
Is
see a
that
lot.
possible?
They're going to see a lot of redness. Yeah. So we're going to see, oftentimes people like to call a total lunar eclipse a blood moon. And what you're seeing is, because the Earth it actually has an atmosphere, light is bent around the Earth. So it's not a complete shadow. And that light is basically all of the sunsets that are happening on the edge of the Earth. And so it's red. That's why the shadow is red, and the moon moves in front of it, and it makes the moon red. So they call it a blood moon. So it's going to be pretty close to a full blood moon.
Alex, I want to get back to the lunar eclipse a little later, because look at this.
All right, there we see
The
it.
partial eclipse. The
Yeah.
partial eclipse has started. This is in Norway.
Oh, wow, that's really cool.
It's very cool. So what you're going to be
That's a pretty
seeing
significant
here,
amount already.
yes, and that's pretty far north on the path. So everybody is seeing this. It's a little different from a lunar eclipse, because when you're looking at a lunar eclipse, it's kind of a whole Earth event.
Right.
Everybody's seeing the same thing at the same time. But with a solar eclipse, it's different, because it's dependent on that dark shadow that we showed earlier moving across the surface of the Earth. And it depends on how close you are to that shadow, and how far north or south or east or west you are. Everybody's going to have a little bit different perspective on it. So the times will vary. So they're showing Norway here right now, in Spain. I don't know if the partial has started, but I would guess not. I guess it.
Well, yeah, it's a good point that you mentioned, because one of the things that's kind of strange is where the moon is actually kind of taking its bite out of the sun changes depending on where you are. So, for example, it's going to get to my area in Baltimore pretty soon, and when it reaches its max in about 45 minutes or so, it's actually going to be at the very top, not on the side like that. And so, because we're at a different location on the globe, we're sort of looking at it at a different angle.
And, I think you've got an illustration, Alex, that really shows that. And let me see if I've got that one up here. I think I do. Yeah, this one. So you can see how the amount of eclipse that you're going to see is getting less and less and less and less and less as you go south on the globe.
Yeah, so I'm at Baltimore, and the amount that we see at Baltimore is, I think, about 3.7, 3.8%, so roughly 4%. And it's going to be very difficult to see with glasses. And I will add, if you're looking at the partial eclipse, no matter where you are, make sure you wear your safe solar viewing glasses. You can only look at an eclipse with your naked eye during totality, if you're in that special part. So, but yeah, there's going to be places that see pretty close to totality, just not quite.
Yes. And Alex, I want to show another one of your charts here. Let's see. Which one should we show? Let's look at this one. Oh, that's the lunar eclipse. Oh, this one. This one shows the path going into Spain.
Right.
Which is where most people are to view today's eclipse.
Most people are sort of in between that 1 minute 57 and that 1 minute 42. They're kind of right in the middle of it. That's probably one of the prime spots. I will say, from looking at the weather maps, I've been looking at them over the past couple of days, that very top part of Spain typically seems to have clouds over it. But once you move down towards more the middle, it's been clear. We were also worried about forest fires because there's a lot of smoke. Actually, I will say the Eclipse toolkit, not only can you add weather maps, but I made it so you can now add forest fires, so you can see where the forest fires are.
Yeah, we got an amazing image yesterday where someone had taken a long exposure photograph of the stars showing what are called star trails. So when you see those trails across the sky, but you could not see the bottom part of the photo because it was dimmed out by smoke. You could see the smoke hanging near the horizon. So this has been a huge wildfire year. And let's go back to the live feed and see what's happening. Still there, still in Norway. Partial eclipse happening. Much of Europe is getting a wonderful, deep partial eclipse. So if you are here from Europe and want to say hi, and Alex, where are we in our timeline? Somebody is saying
the Umbra has just reached Greenland. So it reached Greenland about 2 minutes ago.
And none of the live streams that we know about are broadcasting from Greenland, and it's going to take the eclipse shadow 28 minutes to cross Greenland.
Right.
So, and how much of the eclipse is happening where you are in Baltimore, Alex?
We're right now, it is not started. I think it starts in 1 minute. The very, very beginning of the partial starts in 1 minute here.
Okay. And how much of an eclipse are you going to get from there?
We're going to get around between 4 and 5%. So not as much as you see in that picture from Norway right now. That's maybe double what you would. That's maybe more like 10% or more. So it's going to be a very small amount. It'll be very difficult. I'm looking outside. It looks like it's a little bit cloudy, so I'm not sure yet. In a little while, when it gets close to the peak here, I'll run outside and see what I see.
Yeah. And so no corona for you today.
No corona for me today.
Tell us about the corona. That's what everybody wants to see during the total solar eclipse.
Why don't you go back to that still? Do they still have that still image up of the corona?
I can put it back up. I need to go back over here, and then I need to go to here. And where is it? Here it is. Boom.
Okay. Yeah, so that's the corona. So now this, of course, is a photo, and it's also made by taking multiple exposures. However, I will say that your eyes are even better at seeing the detail than photos are. So you will see that amount of detail for the most part during totality. However, it's going to be much smaller in the sky. But what you're seeing, those streams coming out, those are actually called streamers. That's particles from the sun that are streaming away, following the magnetic field of the sun. And that whole region is called the corona. If you look up, barely visible in the top left, there's a little pink speck there. That is one of those structures I mentioned, those snake-like structures seen from the side. When you see it on the disk of the sun, we call it a filament. When you look at it from the edge, we call that a prominence. But they're basically the same thing. And the really amazing part is all of this corona that you see is where all the excitement happens in terms of space weather. All the activity that creates aurora, that can create a difficult environment in space, that can impact our technology. It all comes from there. So when you're in the path of totality, you are with your own eyes seeing this amazing part of the sun's atmosphere, which for me, the first time I saw an eclipse was fantastic because I'd seen it for decades only from space. And the other crazy thing about it is that structures that you see, they change with the solar cycle. As we get closer to solar minimum, it's going to become much more structured. It gets very chaotic during solar maximum, and you see those spokes all over the place. And every single eclipse looks different. So everyone is unique.
And so that corona, the corona doesn't just come into being because the eclipse is happening, right, Alex? It's there all the time.
It's always there. It's just that because we're looking here at the sun in visible light, in light that we can see with our own eyes. And that light that you see right there is actually being scattered off of all the stuff around the sun. So this is sort of like looking at fog or clouds. It's not glowing on its own, it's reflecting light. But the sun's disk is giving off light, and it's 1,000,000 times brighter. That's why, first of all, it's not safe to look at, but that's also why you can't see all that stuff around it, because that stuff is so faint compared to the disk. So when we have the fortune of having the moon block that bright disk out, then we can see this really, really faint stuff.
But isn't that interesting? Like, I have 3 grandkids, and isn't it interesting when kids draw pictures of the sun, they always draw it with those rays extending out, but they're not seeing, that's not the corona. That's
not the corona.
Brightness.
Yeah.
That's just brightness happening. Yeah. And how far does that corona extend, Alex, did you say?
Oh, it extends for many millions of miles. So
wow.
Yeah, it's very, very big. I mean, the sun is huge. So you're looking pretty far away. And in fact, when you see the corona from the ground with your own eyes, you can actually see much farther out. It's depending on where the eclipse is in the sky. It will get darker, and then you would be able to see even more of the corona.
And so we are EarthSky, and I just noticed, and Jeremiah's our producer. He's here too, invisibly. Jeremiah, if you can get our names popped up here, that would be great. I'm Deborah Byrd, and I'm here with Dr. C. Alex Young, who is a sun scientist, a heliophysicist, and we are here to talk about the total solar eclipse of right now. Let's go back to the live.
Okay, and I actually have an update. The amount of the sun covered in where I am in Baltimore is going to be maximum 4.5%.
Oh, exciting! When is that going to happen, Alex?
That's going to happen, I believe, around 1:45 my time or 12:45 your time. Let me see. I can tell you real quick here.
And we are looking at a stream that was made available to us through our good friends at timeanddate.com. They are so generous with this, and they are going to be broadcasting the totality from Iceland, Spain, and 2 locations in Spain. So what time is the eclipse in Iceland?
It reaches Iceland at 1:43 Eastern time, 12:43 Central.
Okay, so
and let me add for my colleagues in Baltimore, the peak is at 1:52 Eastern time. And if you go to eclipse.thesuntoday.org, you can get to the map and click on it at your location, and it will tell you the timing of the eclipse in your location. And it'll also give you the ability to see what you're seeing here on this live feed. You can go to any location and see an animation that's going to show you exactly that. So you can see what the timing will look like.
Oh, that's such a good idea. And so right now, the moon's umbral shadow is over Greenland. NASA is not broadcasting live from Greenland. The European Space Agency is not. We don't know of any live streams from Greenland at this time, but we can only assume that they're having a wonderful eclipse. At any given location, the eclipse is only going to be total in Greenland for about 2 minutes. This is a relatively short eclipse.
Yes. Yeah. And it's short because the angle is it's just sort of grazing, the shadow's kind of grazing the top of the Earth, and that's why the path is very stretched out, the shadows are very stretched out, but it's moving very quickly, and so totality is very short in any given location.
And I see that Jeremiah got our names put up there, but it's covering our faces. Jeremiah, can you fix that? If not, you can take them down. We don't need our names.
It doesn't look like it's covering.
Like I'm trying to peek around.
Actually, oh, there we go. Yeah.
Yeah. And so we're watching Timeanddate's live stream that they generously granted us permission to view. And so we're looking at the eclipse right now from Norway, and the eclipse is not going to be total in Norway, but I think they started with Norway because it's one of the first places to see what's getting to be a pretty good partial eclipse here.
You can see sunspots on there, on that image. Over to the left side of the image of the sun, there are two little blemishes. Those are sunspots. Oops. And sunspots are where all the activity comes from.
Yes, and there's not that many spots on the sun right now, is there?
No, it's been very quiet for the past couple of days. So, and we've actually been able to see what's on the other side thanks to the solar orbiter spacecraft, and there's not a whole lot at the moment.
There's not much going on. Yeah. Jeremiah, you can take our names off. It's not working. There, thank you. There we are. We came back. We returned. Yeah, we got to fix that. Alex, do we have a second that we could talk about that really cool sun image that came from the National Solar Observatory?
Oh, yes, absolutely. Why don't you pull it up?
One. That is a cool one. Tell us about this.
Yeah, this is amazing. This is from the National Solar Observatory's Daniel Inouye Solar Telescope, which is in Hawaii. So this is the largest, most powerful solar telescope ever, and it produces amazing, amazing images. And these are extremely high resolution images zooming in on a sunspot. And so each one of those flat areas, I think, is about the size of Texas, maybe even a little bit bigger. And then you see all those little kind of flowery leaf-like structures. One of the things that scientists had predicted is that they should see what's called a Kelvin-Helmholtz instability. And many of you have probably seen these in clouds. If you've ever seen pictures of clouds that have these little wave-like structures, like a little wave bending over, that's a Kelvin-Helmholtz instability. Anytime you have two fluids, that's two gases, two liquids that are going over each other, and they have their density is different, you can have one of these instabilities, which makes those really cool little loops, those little waves that you can see on clouds, and we see them all over. And they were predicted, and we're starting to see them now. They're very difficult to see here. There are other images I've seen where they're a little bit easier, but every one of those little wiggly areas is where they're occurring. And sure enough, the predictions of scientists have turned out to be exactly true, and it's just amazing.
And isn't this the highest resolution image of the sun ever taken?
This is the highest resolution image of the sun ever. It is a really amazing telescope, and it has been producing just phenomenal imagery from the sun.
And is this invisible light?
This is, I believe this is invisible light. Yes. I don't know the exact wavelength. But the telescope can see many different wavelengths of visible light. It can see a little bit of ultraviolet. I think it may be able to see a little bit of infrared, which is sort of only the narrow band of the electromagnetic spectrum, the spectrum of light, rainbow, that can make it through the atmosphere. And this is a really phenomenal image, or
It
video,
is.
I should say.
And it's so cool to think that if we had like Superman vision, right, and we could see the sun really close up, this is what we would see.
This is what you would see. Yeah, this is exactly what's happening inside a sunspot.
It's amazing.
Yeah, and this is all the activity, all of this whirling around and this motion is what causes magnetic fields in the sun to get wound up like a rubber band, and eventually they can snap like a rubber band if you wind it too much, and that gives off energy. That's what gives off flashes of light called solar flares. It's what pushes big blobs of material into space. It's really this is the motion that's driving everything. So I've seen that we've got people who've from Portugal, but people are seeing it in Sweden. People are seeing it in Iceland, Canada. So it's pretty exciting.
It is. Let's see. And people are asking how long till the eclipse happens in various places. And I did on the comments on YouTube, I did pin a comment on there that has a link on it that you can click into that link and go to Timeanddate's website and enter your location and get exact eclipse timings. So
yeah, and you can also go to eclipse.thesuntoday.org and do the same thing. So,
oh, Alex, your website's so good.
Well, it looks good thanks to my wife, the designer. So she's the one who helped make it look good. I did the coding and the guts, but she's the one who actually makes it look good. So,
and I want to say one more thing about this image, and that is not just the sun, but other stars too must look like this if you could see them close up without melting your eyes.
Yeah. Yeah, yes, that's very true. There are all sorts of stars. Our star is sort of a medium-sized average star. There are smaller stars, there are bigger stars, but they all have this kind of motion that's, that can vary. They can be very varied in activity. But if we had our supervision, we could see all the same kind of cool stuff happening on other stars.
Yeah, except some of them would be different colors.
Some of them, yes, some of them would be different colors because they're different temperatures. Their size is largely what drives the light that they produce, and that tells you the temperature. And so bluer light is hotter and redder light is cooler.
Ooh, we get some bad news here. NASA's live stream is down.
Uh-oh.
Don't know. Let's see. That was from 12:15. Oh, that was 15 minutes ago. I bet they've got it back up now.
So Totality is going to be leaving Greenland in about 9 minutes.
Yes. And when it does leave Greenland, we're going to have a little bit of action with a total eclipse over Iceland. Mm-hmm. And let's see. Is Timeanddate showing that? I think they are. Let me go to this. Timeanddate has so many different locations where they are broadcasting from. So the feed that we're looking at is broadcasting from, yes, they're going to be in Iceland. They've got 2 locations in Spain. They're broadcasting the partial eclipse from several different locations in Norway, 2 in Germany. They've got 1 in Italy. They've got 1 at the Royal Observatory at Greenwich in the UK. And they've also got a feed from New York in the US and St. John in Canada. So some of these are partial eclipse. The only total eclipse that we're going to be seeing here on this stream, we've got 1 in Iceland. And Alex, how long till that's happening?
We're gonna get to, well, we got to leave Greenland first. That's going to be in 8 minutes, and then it's another 3 minutes to get to Iceland, and then we will be reaching the greatest eclipse about 3 minutes after that.
Okay.
Once the totality leaves Iceland, we'll have about 35 minutes until it reaches the Iberian Peninsula. So until it reaches Portugal and Spain.
So all of you who are watching are getting kind of a view of what it's like to be an astronomer, because being an astronomer involves a lot of waiting.
Oh yeah, so this picture here, this is visible light from the sun with a special filter, but you see those long features, those are the things that I call filaments, that when you look at them on the edge of the sun, they're called prominences, and you can see those as these pink structures during totality, and you can see them with your own eyes from the ground during totality. And those can be some of the things that erupt into space and come in, slam into the Earth, and give us a really amazing aurora show.
And you're talking about those filaments. Those are those dark places
Right.
on the sun. They look like
those
dark
are those
scratches on the sun.
Those dark scratches. Those are the filaments.
Okay.
And that's what you saw on the edge of the total eclipse, on the edge of the moon, where this little pink structure.
Okay, that's wonderful. And we've got all kinds of people watching from all kinds of different places. Some people who can see the eclipse in their sky, and some people who can't. We've got someone from Arizona here, no eclipse from Arizona.
No, unfortunately not. But I will say, we had a lot of excitement in the U.S. in 2017, and in 2024, we do have some big eclipses that are coming up. It's a little ways away, but in 2044, we're going to have one that's going to go through Canada and touch the top of the U.S., I think like North Dakota. But in 2045, that's when we're going to have another big one that's going to go across the country.
Oh, I hope I make it till then, Alex.
Yeah, me too. I think I'll be retired by then, but hopefully I'll survive. So.
Yeah. Okay, we are looking at the view from Leon, Spain right now. And as you can see, the partial eclipse has just started. And Spain, this view from Leon is the exciting one for us.
Yes.
Because we know it's clear there.
Right.
It looks very clear. We don't know that about Iceland for sure. We've been hearing varied reports about what's happening in Iceland with the clouds, but we know that Spain is clear. So we know we're going to get to see a total eclipse, and it's just now started. What time is that totality in Spain, Alex? Do you have that in front of you?
Totality in Spain. Well, the totality in at the beginning starts at 2:26, 1:26 Central. Let me see if I can get a little more specific of when we're actually gonna see it. Let's see here. Okay. Yeah, it's Portugal and Spain. It will start at 1:26 Central Time. And
so stick around, and you are going to see this dark shadow, or this, not a dark shadow, it's an actual silhouette of the actual moon. You're going to see this moon passing in front of the sun as seen from Spain over the next hour, or almost an hour.
So they're in
completely cover it.
They're in Leon, Spain.
Yes, they're in Leon. You can see they've got a little legend down there that says where they are.
Okay,
so they've been changing that. They've been going from place to place because they've got so many viewing locations. Alex, tell us, for those who are in Leon right now, they're anxiously waiting for the totality to begin. And what is that like? Like, what happens? And I know you mentioned the shadow bands, but tell us about that again, because I think people are probably coming and going here.
Yeah,
We
well, definitely that's going to be exciting for them because the sun is going to be very low in the sky. It's going to set at the end of the eclipse. And so because of that, there's the light and that's coming through the atmosphere goes through a lot more of the atmosphere. It's a lot thicker. And what that means is there's a lot more turbulence and scattering. And we can often see that in the form of what are called shadow bands. And they're these kind of wiggly, wavy lines. It's similar to what you see if you look down through a pool and you see the reflections underneath that are wiggling around. So if the eclipse is in front of you, okay, you're looking at during totality and you're looking at the eclipse, right before totality and right after totality, you want to be looking behind you. The shadows will be cool, but you will also potentially on a wall, or in my case, I had a mountain behind me, you could see these shadow bands. And they're very hard to see. So this is actually a really good time to see them if it's at sunset. So that's exciting.
That is exciting. And you guys, it's like you don't get a sense of it. I mean, many people here in the US saw the 2024 eclipse that happened, I think it was April 8th, 2024. And it just passed right across the center part of North America. And, you know, millions of people saw that eclipse. And you really don't get a sense from a live stream like this of what it's like to stand outside and witness a total solar eclipse. It is a really profound and emotional experience because you hear about these stories about, you know, ancient people banging sticks and trying to get the moon to stop eating the sun and that sort of thing. But it's like when you see one, you can understand why they did that, because there's almost a primal terror that goes along with seeing the sun disappear. It's very, very emotional.
Yeah, because one of the things that really struck me is, you know, you see things like sunset and you see it get dark, you know, but it happens over a long period of time, and your body and your brain is kind of used to that. But imagine if that happens over seconds. You know, the change that you would see from bright to dusk happens over seconds. It's so weird, and that's one of the things that's it's such a visceral feeling, because your brain is like, oh my gosh, what is happening? It doesn't happen this fast. And it's really one of the things I found the most exciting is just how much things change around you so quickly.
Right.
Right. And the temperature, that's the other thing, is the temperature change is really amazing.
It gets much cooler.
Yeah.
And it's like the first total eclipse that I ever saw was back in the late 1970s. And we were with these two big dogs, and the dogs were just, you know, roaming all around. But as soon as we were out in a field, out in the middle of a field, but as soon as the total eclipse started, those dogs just came, like truly with their tails between their legs. They just came back. They looked terrified, and they came back and got right next to us because they were scared. They knew something strange was happening. So animals really respond.
Animals really respond. Well, I remember when I was, for 2024, I was in Austin, I was near you, and there were a lot of animals that were reacting. I could hear birds and you know, dogs that were responding, and it was cloudy, but actually the clouds made it get darker because it was cloudy. It actually got darker than it normally would have, which in some ways made it even eerier. So it was pretty amazing. It's an experience. That's the thing, is it's not just what you see. Right. And that's also, you know, obviously seeing the corona is really great and you want to see that, but the whole experience of the change in temperature, the change in light, the shadows change, the colors change, because of the change in the type of light. It's just really amazing. All the different, the sensual, the sense overload is really, really amazing.
Oh, they've got clouds coming in Norway.
Uh-oh.
Oh, they switched back to Spain.
That
Okay,
was a
so the
cool picture, though.
partial, that was a cool picture. So the partial looked pretty deep from Norway, and meanwhile in Spain, the partial has just started. So we are now, the umbral shadow is leaving Greenland right about now, right, Alex?
Yeah, yeah.
And I think in 3 minutes, it'll be hitting
actually,
Western Iceland.
It's hitting Iceland, right? It's just hitting the very edge of Iceland right now.
Oh, it's hitting Iceland right now. Okay,
Yeah.
so maybe Timeanddate is going to give us a view from Iceland if it's clear there, but that's what we don't know. We heard it was cloudy earlier today. So we shall see.
So my wife is out taking pictures with her cell phone and eclipse glasses over it, and I can see a little sliver of the partial eclipse. I'm gonna download it so I can show it.
You can see it with glasses.
You can see it with glasses, she said. So that's fantastic. Okay. So for those of you that might be in the northeast, Washington and up, you're still going to have some opportunities. So
here's someone who is in Maryland.
All right.
And we're just going to stay right here on this stream, because if Timeanddate can show us the eclipse from Iceland, they will do so.
Yeah, so let me show, here's, so we can see this. Here's her phone, and you put the glasses over the camera to safely take a picture with your.
Do you have a picture? We could switch off really quick and look at that.
I'm going to try to do that. So
okay, we'll just stay here until you say.
All right, try to switch over, and I'll put a picture up. It's behind the feed right now.
Okay, so we're going to switch from the live picture that we're seeing here, the eclipse that's happening right now in Leon, Spain. We're going to switch, and there is Norway. They just switched to Norway. The eclipse won't be total from Norway, but they're showing us a deep partial eclipse like that's happening over much of Europe. But we are going to switch right now into an image, not the real eclipse, but an image of an eclipse so that we can see Alex's picture.
So do you know how to move the image? Because it's picked up it picked up the wrong part of it.
Yeah, you have to crop it, Alex, to the size that you have to crop it to a 16:9 ratio.
Before you upload it.
Before you upload it.
All right, well, I'll redo it then.
Okay, we're going to go back to the live feed. Oh man, they're really getting some clouds there in Norway.
Yeah. Oh, let me also say that you can get special binoculars that are made just for the sun. So you can't use regular binoculars, absolutely not, even with the eclipse glasses. But these allow you to see it. Really amazing.
And those binoculars that Alex is holding up there, they're called solar binoculars. I got mine from, look at those clouds. Oh,
other way.
They got an awfully good eclipse there in Norway, though. Those binoculars, those solar binoculars, I got mine from Amazon.
Yeah, I got mine from Amazon. I think they actually come from Lunt. Is one of the makers.
Yes, mine were from Lunt also.
Yeah, they're kind of one of the world's experts on, binoculars, things like that. So, but I got them off of Amazon. Yeah.
Yeah. In fact, I bought the year that we had the solar eclipse here in North America, 2024. I bought multiple pairs of solar binoculars.
Same here. I got
the grandkids.
I got mine in 2017. So.
Yeah. We all got solar binoculars for Christmas.
We're flipping the image, so it's just the wrong aspect ratio. So. Okay.
We are getting reports from various places.
break.
I'm not sure where this person is, but they're saying you can feel the temperature change, and you absolutely can. When a total solar eclipse is happening, it gets much cooler suddenly, but it doesn't last very long.
Okay, I think I switched it now, so let's try it one more time. Oh, I can see it. Yeah, it's gonna show up. There we
There you
go.
go.
See the little tiny sliver there. That's with an iPhone, with putting the eclipse glasses over the camera lens on the iPhone.
Okay, and Alex is in Maryland in the
This is
US.
Baltimore, Maryland. Yeah.
And so he's showing us what his eclipse, where he is right now, is looking like. And you're getting what, a 4 or 5% eclipse at maximum?
It's going to be, what, 4.5 at max?
4.5. Yeah.
4.5 at max. And maximum is in a few minutes. We're going to have a break after it leaves Iceland before it gets to this Iberian Peninsula. So that's when I'm going to run outside and take a look.
Okay. That's cool, Alex. I didn't know that you had done that. And I'm excited for people to know that if you have eclipse glasses, you can hold them up over your mobile phone's camera, in front of the camera.
In front of the camera. Yeah.
Not behind the camera, but in front of the camera. And you can use your phone to take a picture of the
Just
eclipse.
be careful when you hold your phone up to not look up at the sun. You know, you just want to, if you glance at it for like a split second, it's not going to hurt you, but just don't stare at it.
Yeah. And don't glance at it.
Yeah.
Don't glance at it either. Okay, Norway, that cloud went away. That's nice. I guess they're showing this because it's as close as they can get to Iceland, where the totality is happening now. And this says to me that they are clouded out in Iceland.
Okay.
Clouded out. Yeah, we heard that this morning. We heard that Iceland was cloudy.
I'm going to take a quick break so I can run outside and take a look at what we're seeing here in Baltimore.
That sounds great.
So I will be right back.
Okay. And so my name is Deborah Byrd, and I am EarthSky's editor-in-chief. And I am here every Wednesday at noon Central Daylight Time, or in the summers, that is 17 UTC. Next week, I'm going to be talking about the eclipse of the moon. So eclipses happen in what astronomers call seasons. And this eclipse of the sun, eclipses never happen in isolation. When there's an eclipse of the sun, there's almost always an eclipse of the moon that happens 2 weeks later or 2 weeks prior. And sometimes there's 3, sometimes it'll be like lunar eclipse, solar eclipse, lunar eclipse, that'll happen over a 6-week period. But for this particular eclipse season, as they call it, we're having a fantastic lunar eclipse for North America that's coming up, and that's going to happen overnight on the night of August 27, 28. So I'll be back here next week at noon Central Daylight Time or 17 UTC to give you all the details on that total lunar eclipse. And so what's happening basically is that when the Earth, Sun, and Moon get aligned just in the right way for an eclipse to take place, it takes a while for that alignment to change. So 2 weeks later, when what happens in a solar eclipse is that we on Earth are looking toward the moon, and beyond the moon is the sun. So the moon is in between the Earth and sun. What happens in a lunar eclipse is that we on Earth are in between the sun and the moon. So the Earth's shadow is falling on the moon, and that's what's making the lunar eclipse. Lunar eclipses are all about shadows, and solar eclipses are all about a solid object, the moon, moving in front of the sun. So that's a big difference there. They're both beautiful and incredible. And as Alex said earlier, this lunar eclipse is going to be, I think it's going to be 93, 94% in the shadow. It's not going to be a total lunar eclipse, but it's going to be so close to total that you're going to see many of the effects that you would see in a total lunar eclipse. So for example, you should see the shadow on the moon begin to turn that blood red color that people talk about. People call lunar eclipses blood moons. And so you should be able to see that for this eclipse coming up on August 27, 28. Great eclipse for North America. And it doesn't even happen, I mean, it starts before midnight for much of North America. So that's unusual too. A lot of times for these astronomy events, you have to get up really early in the morning. Oh, and speaking of that, speaking of astronomy events that you have to get up early for, the Perseid meteor shower is happening right now as we speak. We're really hopeful that someone somewhere in the world is going to capture an image of a meteor streaking past the sun and moon while the sun is eclipsed by the moon. So we don't know if we'll get that image or not, but we hope we will. We're right at the peak of the Perseid meteor shower. So if you had gone out this morning, wherever you are in the Northern Hemisphere, the Perseids is not a great shower for the Southern Hemisphere. If you're pretty high up in the Southern Hemisphere, or I don't know if you say high up or low down, but if you're pretty close to the equator in the Southern Hemisphere, you can catch some Perseids. But in a lot of the populated areas in the Southern Hemisphere, the Perseids are below, the radiant point is below your horizon. It never comes up above your horizon. So the Perseids is just kind of not a big deal from the Southern Hemisphere. You do have another meteor shower. There are actually two meteor showers that go on at once that are sort of overlapping at this time of year. And from the Southern Hemisphere, the other meteor shower, the Delta Aquariid shower, is a good shower. So you can see some meteors right now. Timeanddate is now going back to Norway. Wow, Norway's having a really beautiful partial eclipse, as is much of Europe. So 2 years ago, at the total solar eclipse that happened across North America, the April 8th, 2024 eclipse, that was North America's turn, but really this time for this eclipse, it's Europe's turn to have this great eclipse. There's going to be an even more exciting eclipse for all of us that's going to come up next year in 2027. There's going to be, I think it's the longest total solar eclipse of this century. If it's not the longest, it's definitely one of the longest. So the total part of the eclipse for today's eclipse lasts about 2 minutes, but the 2027 eclipse, the total part of the eclipse lasts over 6 minutes, 3 times as long. So what that means is that you'll be standing out there looking at the partial eclipse. It's daytime for most of the time while that's happening. The light does begin to get very eerie, like when you've got this much of an eclipse going on, everything around you is starting to look really strange. Like just the quality of the light really changes. You begin to see those little crescent suns underneath all the trees. There's little crescent suns are on the ground everywhere. I'm sure they're seeing that in Norway right now. Maybe you saw that with the eclipse in 2024 or some other eclipse that you've seen. So, but if you've got a longer eclipse, if you've got an eclipse that's lasting for 6 minutes, what that means is that the sky is going to get dark for 6 minutes while the moon is in front of the sun. So you should get quite a few stars popping into view. We're thinking at this eclipse, people will be seeing the sky's 2 brightest planets, which are Venus and Jupiter. Venus is in the evening sky, Jupiter is in the morning sky. And what that means is they're both pretty close to the sun right now. They're not on the same side of the sun. One's in the evening, one's in the morning, but they're both pretty close. So for today's eclipse, you'll probably see images that people caught of both Venus and Jupiter during totality. But during a 6-minute eclipse, you will probably see a lot more stars pop into view. So your sky will probably get pretty dark during that 6 minutes. And every other eclipse effect will be accentuated as well. So the temperature will drop more, just the whole awe and kind of primal terror of the experience will last that much longer. So the 2027 eclipse is going to be a really good one. And the center line passes through Egypt, which would be a really fun place to go to see an eclipse. So I'm sure lots of people have already made their arrangements to go to that eclipse. We are here looking at the stream from timeanddate.com. And I think we'll just watch for a minute without me talking. I think Alex is about to return. There he is. Hey, Alex.
Hello.
What did it look like?
Oh, it was really cool. Just slightly more than the picture you saw before. I looked at it with one of our solar binoculars, which was cool. I tried to take a picture. I'm not as good as my wife, and it didn't come out as nicely as her, but still, it was fun.
So we were talking about the 2027 eclipse that's going to have a 6-minute totality.
Yes.
And one of the cool things that happens during eclipses, and Alex mentioned it before, but it looks, as you're standing there waiting for the eclipse, like just as the moon's shadow begins to rush over you, you see what looks like a 360-degree sunset all around you. Like you start to see it, and it's kind of moving, because how fast is the moon's shadow going, Alex?
Well, right now it's going at about 3,400 kilometers an hour. It's going to be slower in 2027, which is why you get to see more. It's going to be more like about 1,700. It's about half the speed when it goes across North Africa.
Yes.
It'll be the second longest eclipse of the century, and it's actually only shorter by a few seconds than the longest one, which was earlier in 2000 over China.
Oh, that's right. That's right.
So
I'm remembering that now. So since we are getting, and again, this feed is from Norway. Norway is not going to get a total eclipse. And what we're really waiting for at this point is the total eclipse as seen from Leon, Spain. We're hoping that we also get one of the last views of the eclipse, which will happen, that's like about, let's see, that's about 1834 UTC for those last views, Alex, is that right?
correct. A little bit before that, yeah.
A little before that, yeah. So in the next half hour or so, we are going to see a totality from Spain. We're definitely going to see that totality from Leon, Spain, because it's clear there and they're set up to go. And so let's talk about some of the things that people can see just before they get to, here we are in Leon again. So we're waiting for that moon to move further across the face of the sun, bringing totality to Leon. And
yeah, so totality is going to begin in Leon. Let's see, it's going to be around 1:28 Central Time or 2:28 Eastern Time. So about 27 minutes from now is when totality should get to Leon.
So if you were there in Leon right now, you'd likely be standing in a big crowd, because when an eclipse happens, people just come out. Like even if you try to go to a park or something and get someplace where it's relatively empty, there'll still be people around. There's always, everybody's out, you know? And so right about now, when the moon is this far in front of the sun, people are watching with their eclipse glasses, and very likely someone in that group has a telescope set up where you can see a really good view like this. That's what we're looking at here, is a view through a telescope.
This is a little weird because the time up there says 1:14, so that's not.
Oh, that's how long we've been broadcasting.
Oh, that's how long we've been broadcasting. So what's the time in Lyon? Does it say?
That I don't know. In Lyon, I don't know the time in Lyon. Let's see.
Okay.
Spain is 7 hours ahead of Central Time, and I think it's getting pretty late there. I think that in Spain right now, unless I'm wrong about the time conversion, I think it's getting on toward evening in Spain.
Yeah, it's 8 p.m. A little after 8 p.m. in Spain right now. So
a little after 8 p.m.
So their totality begins in 25 minutes.
Yes. And so what's happening now is just there's this electricity running through the crowd. People are getting excited. So Alex, tell us some of the things that are going to happen just as totality starts. Tell us about Bailey's beads, and tell us about the diamond ring.
Yeah, so the moon, one of the really cool things is the moon is not smooth. It has mountains, and they're actually quite large mountains. And so when the moon gets just to the edge of the sun and it's almost completely covered, the last little bits of light will go through the valleys in between those mountains. And those little valleys will give little specks of light, little beads on the edge of the sun, which are called Bailey's beads. And then you'll get the last little bit, which will be a very bright part that makes it look like, they call it the diamond ring, because you can start to see the edge of the corona, which is the ring. And then you see this really bright diamond structure, and that little last bit is the diamond ring. So as that's happening, you're seeing the fact that the moon is in fact got mountains on the edge of it. And one of the cool things about that is that that's also determines the shape of the shadow, because the shadow is not actually nice and smooth. In fact, those different little mountains are like little spotlights, and they all add up, and it turns out that the shadow has these kind of sharp edges because of that, which scientists didn't think was real until they did a strong enough computer simulation and realized that that's exactly how the shadow is.
And it's such amazing, like one of the most amazing things about eclipses is that the sun and moon are exactly the same size in our sky. And that's a coincidence. That's kind of a supremely remarkable coincidence.
It really is.
It's not always going to be that way.
No, it won't be. It won't always be that way. Now, fortunately, it's going to be several 100 million years before that changes. But what's happening is the moon is moving away from the Earth a few centimeters every year, and we know that because we put reflectors on the moon during Apollo, and we bounce lasers off of it, and we can actually measure that change. And that's one of the really interesting things, that we're in this unique period where it's just perfect.
And Alex, one of the first places they did that was McDonald Observatory in West Texas, where I was working.
Oh, that's cool.
In the 1970s. Yeah, cool. They were doing they call that lunar laser ranging. So they're ranging the moon. They're figuring out where exactly how far away the moon is. So the astronauts who first went to the moon left these. Were they mirrors? Were they actually mirrors?
I think they're mirrors. Yeah.
I think they're mirrors too. Something reflective. So if they're not actual mirrors like what you would look in, it's something reflective like that. And so they go out there and they know where they are on the moon. The astronomers know where to aim the laser, and then they fire this laser up there and it hits those reflectors, and they can measure, as Alex said, they can measure how long it takes for the light to come back. and they can find out exactly how far away the moon is.
Yeah,
so
and
the moon's getting farther away.
It is. And, that's actually one of the interesting things about calculating eclipses. I mean, building out my own tool, spending time learning how to calculate the information about eclipses. And that change in the moon moving away, which also relates to how fast the Earth is rotating, is changing. And we don't know how much it changed over time. When you go backwards in time, did it change at a slower pace or a faster pace? How did the change in the speed of the Earth's rotation change? And that's actually a very important calculation in eclipses, and why it's challenging to get, a very, very accurate answer, especially as you go far into the future or far into the past.
Right. And it must have been that look, here's an interesting comment. Even the birds stop singing. So true.
Yeah, it is true. It is true.
They think it's night. It's like when you have a parakeet and you cover it with a thing to make it think it's night.
Exactly. I haven't seen this myself, but I've heard that farmers have seen some of their animals go back to the barn thinking that it's, nighttime, chickens and cows and things like
cows,
that.
Yeah.
Yeah.
Oh, yeah. Yeah. I don't know if I've seen that or not. I know I saw with those dogs that I mentioned earlier but
I've heard the changes in the sound. I haven't actually seen the animals, but I especially heard it in 2024, how the response of the animals changed as the eclipse progressed.
Here's a comment from a member of the EarthSky team, Armando. Hey, and he's talking about his solar binoculars. He's using them to look at sunspots.
Yeah, and you can actually use those and see the sunspots right now.
Yeah, but there aren't very many sunspots.
There aren't very many. They're very small, but you can't see them with just the glasses. You need the special binoculars.
Yeah. So actually, this maybe is a good time to talk about what we're seeing on the sun's surface, because there's not much that we're seeing there. So that hook-looking thing, that upside-down J, what is that, Alex? Tell us about that.
That is a filament. That is another one of those. You mean the dark structure there?
Yeah.
Yeah, that's another one of those filaments that, again, it's actually sort of high up in the solar atmosphere. You can't see that because you're looking down on it. But when the sun rotates, that will be on the edge, and you will be able to see that structure sitting off the sun. And those structures often erupt into space. There's billions of tons of solar material. And when those structures are pointed towards us, that eruption of that big blob heads towards us, and it rattles the Earth's magnetic field, creating electrical disturbances. And it also accelerates particles into oxygen and nitrogen in the atmosphere, and that gives us all the amazing colors we see during the aurora.
Yes, and let's talk about those big blobs of stuff from the sun that come to us on Earth for a second, because we haven't mentioned this. We get a lot of people asking about the Carrington event that happened in 1859, and people are really interested in that. Give us your opinion. Could there be another Carrington event, and what would happen?
Well, there very well could be. As I mentioned,
tell us what it is first.
Yeah,
what
so
it is.
Back in 1859, Richard Carrington, a British astronomer, was looking at a sunspot, and the sunspot all of a sudden got blurry and bright, and what he saw was called a solar flare. So that's just a big flash of light over all of the different spectrum of light. And what also happened is a few days later, there were huge electrical disturbances, which were picked up by telegraph lines. The telegraphs were running without being plugged in. People were electrocuted by the telegraph lines. Magnetic measurements all over the world fluctuated very, very rapidly. And we saw aurora. northern and southern lights all over, very far south, incredibly bright for several days. And that's when Richard Carrington and others made the connection that what was happening on the sun a few days later caused aurora, and it was magnetic in nature. And what happened was, when he saw that big flash, that big flare coming from a big sunspot, one of those big blobs erupted, and it traveled through the solar system, but it cleared the way. It cleared out all the other stuff, all the other solar particles, and another big one came after it. And it sort of created this, what we call a perfect storm. And so that was a giant blob. We call it a coronal mass ejection. So it's mass, stuff from the corona. And that hit the Earth's magnetic field, causing these fantastic magnetic disturbances, which were picked up by telegraph lines and created the aurora. But it turned out, we've estimated that this was the largest such event that's happened in several hundred years. And it's considered kind of a standard candle for a giant, potentially huge impact, could have a huge impact if it happened today. Estimates are that there could be billions to trillions of dollars in damage to our power grids and our equipment, because this thing is electromagnetic in nature. It impacts technology. And so we use that, it's called the Carrington event, and we use that as a standard measurement of what a giant event would be. And the question is, can it happen again? Well, events, large events, not as big, but big enough to cause problems, have happened. They've happened in the 1920s, 1920. Railroads, electrical systems and railroads were impacted by a giant storm. They happened in the 50s. And then most famously, in 1989, a storm was large enough to knock out the hydropower in Quebec. So millions of people were out of power for many hours. It even, impacted the Northeast. And then there were another big series of storms in 2003 in October, November, that are now called the Halloween storms. So those events were big, but not as big as the Carrington event. Maybe the Carrington event was maybe 2-3 times bigger than those. And just like a big flood, you hear people talk about this is 100-year or 1,000-year flood. The big events happen very infrequently, but they do happen. And so there is the possibility that we could have one tomorrow, 10 years from now, and that's what scientists both want to understand and prepare for. And as I mentioned, these big events, including the Carrington event, tend to happen as we're leaving solar maximum going into solar minimum, which is where we are now.
Right.
So, so that's something that we're keeping our eyes out for. And we've had some experience in this solar cycle with the May event in 2024. That was a very large event. There were impacts to technology. There were impacts to the power grids. Fortunately, they seem to mitigate that problem, which is a good thing. But we did actually find that GPS was impacted, and that caused losses in precision agriculture, because many tractors use GPS, and over that weekend, many millions of dollars in crop yield was lost due to that event.
And what's so strange about this story to me is that I'm sure of the 1,356 people who are watching us right now, somebody's going to get on here and say, it'll end civilization, because there's always somebody in every crowd who says that. There's a huge
fortunately,
group.
I don't think that's going to happen.
No.
No, it's not going to happen. However, it will have an impact, and it could be a substantial impact. It's not going to end civilization. I've certainly heard my share of doom and gloom about that, because we watch it. We know it's coming. We also know how to address it. Are we perfect at that? No. But it's just like, 30, 40 years ago, or even before that, hurricanes may have had a bigger damage because you didn't have satellites that were looking at them in the same kind of detail. We didn't prepare. We didn't build things different. We didn't build for that sort of stuff. And that's where we are now. We know how to prepare for a lot of it. Every day we get better at this, and we improve our science, which is one of the reasons why science is so important, because that science drives the ability to mitigate these kinds of things, to know that they're coming, and it's potentially going to cause some negative impact, and it could be, it could cause some monetary loss. We've already seen that, but it's not going to end. It's not going to be this devastating kind of thing. That's
and one reason for that is because it's not like, when it was realized that the Carrington event had happened and had been this big event and had done all of these things to the technologies in the 1850s, scientists began looking at it and studying it, and not just scientists, but also electrical engineers. I did an interview maybe a year or two ago with an electrical engineer who is on a committee, a national committee here in the United States, who they have been meeting year after year after year, trying to figure out what would happen if a big solar storm hit and took out a bunch of transformers, so that now the electrical grids tend to have these easily replaceable transformers. So it's not a situation anymore where a solar storm can come in and just knock out a whole system. It's more like they've got these modules that they can pull in and out.
Exactly.
So the power could go out, but it's not going to stay out permanently. It's like, I think what he told me was you might get some power outages that would last for a week, which would not be fun. We had the power out here in Austin, Texas for 4 days in the middle of a snowstorm, and that was awful. But you never want your power to go out. But it's not going to end civilization. Right.
I've experienced that. I used to live in Florida. I've experienced bad hurricanes. Actually, years ago, I was in high school, and the city lost power for a week. So, it's terrible, but
it is. It's terrible.
It changes. It gets better. So you're exactly right. It used to be that we depended on these single giant transformers that were difficult to make, were expensive. And so if it went out, then it was a big problem. But like a lot of things, we've made things modular. We've made things, replaceable, so that it's not dependent on one single thing, but lots of things that you can, mix and match and take care of. So that's what's happened because we've been studying this for decades. Thanks to the engineers and thanks to the scientists.
Alex, look.
It's getting close.
It's getting really close. Okay, so now we're back in Leon, Spain, and the moon is about to cover up that big J-shaped structure, that dark J-shaped structure. It looks like a circle right now that the moon is covering, and that is a filament on the surface of the sun. It's like a big canyon, isn't it, Alex?
Yeah, it's a canyon with stuff floating over top of it. And that's the prominence you see. So I'm looking at the timing, and we're about 7 minutes away from the beginning of totality.
Okay, and the totality is only going to last 2 minutes.
Yeah, it's going to be fairly short.
Do we want to like take a break from talking and just listen to some music?
Yeah,
so that we can
do that.
Everybody can kind of get prepared to watch that totality.
Yeah,
it's coming up very shortly.
I think that's a good idea.
Okay, so we kind of disagreed over which music we should.
I like what you picked. So, but I'm a sci-fi person too. So yeah.
Okay, I kind of picked this sci-fi music. So we're just going to let this run for a couple of minutes so that you guys can take a break if you need to, and come back and catch the totality in Leon, Spain.
Yeah, you've got
So-
about 6 minutes, so good time to take a break.
Yeah, and I'm going to take a break too. So we'll be
Okay.
right back.
All right.
Wow, you can see right now on the edge of the sun a prominence. That little red thing sticking up, that's actually on the sun. And that's just what Alex was talking about with the filaments. When you see them on the side of the sun like that, they're called prominences. We are just minutes from totality in Leon, Spain.
I'll put it on afterwards. Oh, my name was shut.
Hey,
Hey, that's a prominence, right, Alex?
it is. It certainly is.
So if you were standing there watching the eclipse, I don't know that you'd be able to see that with the eye yet, because I don't know that it would be dark
No,
enough to see
you
it.
won't be able to. You wouldn't be able to see that until totality.
Right. So how many minutes till totality in Leon?
We have got 1 minute till totality.
1 minute. 1 minute, you guys.
I'm behind you.
Okay.
I just was on the screen.
It's okay.
Can I tell them you're here?
Yeah, my wife is standing behind me, behind the Pleiades.
Hi, Linda.
The eclipse party.
And you know that the folks in Leon right now are excited because they can see the eclipse.
I might scream.
Okay.
Wow, look at
That is a really nice
that.
prominence.
That is really.
That is a beautiful image, and I want to thank our friends at Timeanddate for making this stream possible for EarthSky viewers.
Yeah, it's a prominence as a filament. It's on the side.
Here we go. And you should be able to see that wispy corona come into view around the sun as soon as the moon covers the sun completely.
So we're not in Spain, but we're watching
And now I'm wondering if they've got some thin clouds there.
They haven't switched the filter yet.
Oh, the filter. Ooh.
Oh, you can tell you lit up. That's totality.
Yeah, that's totality.
Wow, great view of that prominence. Ooh.
Here we go.
Wow, a totally eclipsed sun in Leon, Spain. And you can see more prominences now on the opposite side of the sun. Those little dots just sticking up over the edge are the prominences.
Yeah, so this is what they're seeing from the ground, much, much smaller in the sky. You're seeing all those little prominences, and some of those are Bailey's beads. We're looking through the mountains of the moon.
Looks like they've got a cursor of some kind. They're showing
Yeah.
something.
Yeah, on
And
the ground, they would see the corona streaming out from the disk.
Oh my gosh, it's already over.
They didn't flip the filter.
No, they didn't change the filter, did they? Maybe they'll do it in Mallorca. We've got one more totality to go, you guys. It's coming up very soon.
It's a lot of structure on the edge, though.
It's very interesting. And you know, one reason we see the moon there, that black thing in front of the sun, is the moon. And oh, they're going there now. We're in Mallorca, so we're going to see the totality here. The totality is almost simultaneous. Whoa, there's the corona.
Linda.
Yay. They're trying to give us a good view. I don't know what there's some distortion on the bottom part there.
Yeah, but that's the corona because they turned the filter off.
Right. And that wispy corona is extending for millions of miles into space.
Miles, yeah.
So the distance between the Earth and Sun is only 93 million miles. So it's a big structure there in the middle of the solar system.
It is. So you can see the wispy stuff on the edge. If you were looking with your own eye, it would be a lot smaller, but you would actually see more detail than the camera can pick up with your eyes.
And I don't know why we're seeing all of this distortion on the camera, but I do know that in Mallorca, they're seeing the eclipse when the sun is really low on the horizon.
Yeah.
And so they may be trying to compensate for some atmospheric distortion.
Maybe so.
After these live streams are over and after the eclipse is over, do look around online, come to earthsky.org and other places to see photographs of the eclipse that were captured by individuals, because I bet if you were standing there looking at it, you would see these amazing sunset colors and other beautiful things happening with this Mallorca eclipse, because the sun is so low. The eclipse is still going on somewhere on the Earth, now passing Mallorca, but that part of the Earth is going into nightfall. So for us on the Earth, it's ending.
Well, it's been great that Timeanddate have given us this feed. It's really amazing.
It's very kind of them to do that. And Timeanddate has other media partners that are also using this feed. So I don't know what's going on with the NASA feed and the European Space Agency, but there are definitely, we're very grateful to them. And
they have some amazing, I'll say they have some amazing resources. Actually, what they have for eclipses was sort of an inspiration for me, that and the work of the visualizer, Ernie Wright, and the work of Fred Espenak, who developed the 5,000-year catalog. All of those were what inspired me to make my tool, which I'm hoping is sort of complementary, because I get into a lot of the numbers and the nitty-gritty too. So to have. And
Alex, tell us where we can find your tool.
Yeah, so go to eclipse.thesuntoday.org, and then my main educational site that I build with my wife is thesuntoday.org, and that's where we are on social media, Sun Today, and it's been a passion of mine to be able to share all this, and I'm so excited that these days I get to do it with you and with EarthSky. So it's continued to be such a joy to be able to have this opportunity to talk about all of this.
Yeah, Alex, thank you. We are EarthSky, and I'm Deborah Byrd, and I'm here with Dr. C. Alex Young, who is a heliophysicist or sun scientist. And I'll be back next Wednesday. We're gonna, I think what we're gonna do here is we are just gonna leave this stream up, but Alex and I are gonna say goodbye, because what's gonna happen now is that the everything that we just watched for the past couple of hours is gonna happen in reverse.
Exactly.
Yeah. So the moon is now gonna move away from the sun, and you can see how red the sun is here, and that's because it is sunset in Mallorca. So look around for some photographs. You're going to see some spectacular photographs from that little island off the east coast of Spain. It's going to be beautiful. We're hoping that people will submit photos to EarthSky's community page. So if you would like to do that, come to earthsky.org and hit the community button, which is on any menu bar on any EarthSky page, and check that out. Also come and visit Alex and me and a bunch of other people at our daily sun news update. So we update that every single day. And we would love to have you come and check out what the sun is doing every day.
And
We've been doing it for years.
I'll end with my partial eclipse glasses. I have, this is my partial eclipse. There we go.
Okay, that's great. Well, I am going to sign off. Thank you, everybody, for being here. I'm so excited that you all came to see us. Come back and see me a week from today. I'll be talking about the great partial lunar, not that much of a partial, it's almost total lunar eclipse. It's going to happen on August 27, 28, and I will be doing that 1 week from today on Wednesday at noon Central Daylight Time or 17 UTC. Alex, thank you.
Thanks, Debbie. Bye-bye. Thanks, everybody.
Bye. Hello again, guys. Hey, sorry about that. We popped you off for just 1 second, and I wanted to answer a couple of questions. So here is a question from John V, I think that's a 1V1R7S, and he wants to know, where's the stars? Where are the stars in this view? And John, the reason we can't see stars, it isn't because they're, well, if you were standing out there looking at the eclipse, you might see a star or two pop in, but you cannot see them because of the camera's exposure settings. So even though it looks to us like this is faint and we're not seeing the corona of the sun right now, that the moon has moved away, but what is happening there is that you're looking at a really, 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 really bright sun. And in order to be able to just not have it look like a brilliant blur, like it would look as if you looked up at the sun with your eye, you know how you can't look at it. In order to have that not happening on the screen here, the camera's exposure settings have to be really low. And that's why we can't see the stars. You might be able to see with your eye. You wouldn't see the Milky Way in any case. It doesn't really get dark enough during an eclipse for the Milky Way to pop into view. It's got to be darker than that in the sky. At this particular eclipse, the planets Venus and Jupiter are pretty close to the sun. So people who are seeing this probably can see Venus and Jupiter. I haven't heard anybody say that yet, but I bet they can. And but this camera is not going to pick it up because it's just too, like, if you were looking at this right now, if you were standing there looking at it, you'd have to be wearing eclipse glasses to see it. So I'm going to pop out again, and I might be back to answer some questions. So the eclipse in Leon, Spain, which is the primary place that our partner, our streaming partner, Timeanddate.com, was recording from and streaming from, that eclipse looks like it is over. And it looks like what they're now doing is showing us some images. This is a beautiful image from Norway. They're showing us some images of the sun from various places where they were had partners. They had an amazing group of people that they were streaming from multiple locations. So they were streaming from Leon, Spain, Mallorca, Spain, and also Iceland to show the total eclipse, but many different places where they were showing the partial eclipse. And it was just beautiful. So I sure do want to thank all of you for being here. And we are grateful to you for coming. Just a reminder, I'm Deborah Byrd, and I am going to be back here 1 week from today. I didn't look at a calendar. Let's see. The 19th? Something like that. Wednesday. It's going to be a Wednesday. I'm always here on Wednesdays. At around noon Central Daylight Time or 17 UTC in the summertime. And we are, as I said, we are grateful to our partner, Timeanddate.com, for providing us with this feed of their live stream. We really enjoyed it. I was here with Dr. C. Alex Young for most of the eclipse, and we had a good time. So thank you all for being here. I am going to sign off. Just want to say thank you again, and please join me 1 week from now. Thank you, everyone. One Earth, one sky, EarthSky.